Hello everyone. The topic for today's lecture is creating functions. Last lecture, we learned how to use functions like print, input, type, typecasting functions, and so on. In today's lecture, we are going to learn the syntax for creating our own functions. We are going to learn how to provide input to a function and how to obtain output from a function. Finally, we are going to learn how to trace a function call execution by going through examples in Python tutor. I hope all of you have been able to keep up with the reading for this course. You have more reading from chapter 3 of Downey book for today's lecture topic. In addition to that, you have a custom reading called as Creating Fruitful Functions, which was created by Tyler. The link to this reading can be found on the course website schedule page. This custom reading lists 301 as the course number. Just please ignore that. The reading is still applicable to CS220 and CS319. I'm going to go back to the robot problem which we covered as part of the pseudocode lecture. Recall that we had a very dumb robot which was just capable of moving one step at a time. Then we created move code which enables the robot to move n steps where n is provided as input to move code. Today's lecture is going to be about writing functions like move code in Python. There are two types of functions in general. Type 1 would be functions which do something. Example would be move code. You can also think of functions which use the print function call to display output onto the screen. Type 2 would be functions which produce values. Downey calls these functions as fruitful functions. Type 2 functions return a value. Examples of type 2 functions would be mathematical functions. Sometimes functions both do something and produce a value. We are going to go through an example mathematical function which will enable us to understand the syntax for creating functions in Python. Here is a math function definition which says f of x equal to x squared. Let's compare and contrast the math definition to the Python definition. Let's look at the similarities first. The function name is f in both the cases. Then you have x, which is parameter in Python world. Recall that parameters are special variables which enable you to provide input to a function. Then you also have the parenthesis, which is a common factor. Let's talk about the differences. In Python, you need to explicitly use the def keyword, which is in short for definition, in order to define a function. Following the def keyword, you need to provide a space. Then you have the name of the function, open parenthesis, close parenthesis, and the colon after that. The colon can be thought of as equivalent of equal to in your math definition. Within the parenthesis, if you have parameters, you list them by using comma as a separator. In this particular example, you only have one parameter which is x, so you only list x here. The second difference here would be that you have to use the return keyword in order to produce certain expressions result from the function. For example, the math definition computes x squared. Recall that the corresponding expression in Python would be x double asterisk 2. You'll have to type in return keyword in front of the expression, and you need to have a space in between return and the expression itself. The third difference here is that in Python, you need to indent your function definition lines of code using a tab space. Alternatively, you could use 4 spaces on your keyboard, but I would recommend you to stick to using tab as your indentation. Here is another function example. The math definition is g of r equal to pi r squared, which is computing the area of a circle given the radius. You can take the math definition and try to write a Python function as such by using g and r as the function name and the parameter name. Alternatively, you could use descriptive words like get underscore area, which give a better sense to somebody who's going through your code instead of just using the function name of g. You could also use radius instead of r, which is more descriptive. In Python, you're allowed to have many number of lines of code within the function definition. For example, instead of using radius as the parameter, you could define diameter as the parameter, and you can think of adding a radius computation line inside the function definition here, which computes diameter divided by 2. All of the lines of code within the function definition should be indented using the tab spacing. Python doesn't really care too much about the spaces that you use after a variable name or the spaces that you use within the expression, but the tab indentation in front of the lines of code within the function definition is very important. You'll eventually learn other ways where you can use colon, and you'll have similar tab indentation for all of those syntax as well. We are going to go through a few examples for simple mathematical function definitions. Let me switch over to my terminal. Let's see where we are. I'm going to type in the pwd command. I'm in my favorite documents location for CS220. I'm going to create a directory called lecture07 by typing in the mkdir command. I'm going to next move into this directory by typing in cd lecture07. Then let's launch a Jupyter Notebook session by typing in Jupyter space notebook. I'm going to create a new notebook file by clicking on new Python 3. Let me rename the notebook file to be main here. So what we are going to do now is, I'm going to provide you examples to these three functions where we are using the built-in functions in Python. After that, we are going to implement our own version for each of these functions. So let me first show you the built-in ABS function. Let me go through a couple of inputs here. I'm saying ABS of -10, which provides output as 10. ABS of 10 provides output as 10 as well. I'm sure that all of you have been able to guess that ABS stands for absolute. So let's try and create our own definition for absolute function. Notice that when I typed ABS, the word color changed to green. So that means that I should stay away from using that particular word for a variable name or a function name. How can you come up with function names? Apply the same rules as variable names. One more time, the Pep8 style guide recommends you to not use camel case for function names in Python. Instead, you need to use underscore to separate between two words. So I'm going to use absolute as the name for the function that we create. So let me type in def, and then I'll type in space, and then I'm going to type in absolute, which is going to be the name of our function, open parenthesis, close parenthesis. Within that, I'm going to configure x as the parameter name. Notice that when I typed the colon and typed enter, Jupyter Notebook automatically indented the next line with a tab space for me. Jupyter Notebook is awesome in that way. So let's try to compute absolute of a number. We have a very easy mathematical way of doing that, correct? You can square a number and take a square root of it. So I'm going to say x to the power 2 and then that to the power 0.5. So I can run the definition for this function by pressing shift and enter, then I'll be able to invoke or call the function. Recall that in order to invoke or call the function, you'll have to type in the name of the function, which is absolute, and then you'll have to type in whatever is the argument that you want to pass. Let's try absolute of 10. Looks like that's giving us 10.0, and absolute of minus 10 is also giving us 10.0. Why did we get 10.0 instead of 10? Recall that when you are taking a square root of a number, your return data type will always be of floating type. That's why you're getting the result here as 10.0. If you really want your result to be an integer, you can think of typecasting the result of this expression using the int typecasting function. Next, we are going to move on to square root function. Let's try sqrt of 16. That did not work, correct? This wouldn't work because square root is not a built-in function. So I'm going to just type in not a built-in function. And let me show you how you can use the square root function. Square root function is part of a module called as math module. What is a module? Module is nothing but a collection of similar set of functions and associated variables. How can we import a module? There are a couple of ways to do that. I'm going to teach you one way now. During later part of today's lecture, we are going to learn the second way of importing a module. So the first way would be for you to type in the keyword from and then say the name of the module, which is going to be math, and then space, import, and you can say the name of the function, which is going to be sqrt here. To repeat whatever I've typed, I typed in from math import square root. Now we should be able to call the square root function by saying square root of 16. Let's try to implement our own version of the square root function here. I'm going to type in def and type in square underscore root as the function name. I'm going to configure my parameter as x. Computing square root is very simple. We just need to say x to the power 0.5 here. While creating the definition of the function, you will be able to also call the function within the same cell. For example, I can call square underscore root of 16 here. When I run this cell, I'm creating the function definition and also calling the function here. Notice that when we created the definition for absolute function, we did not actually call it within the same cell. So in order to use a particular function, you'll have to call the function explicitly after having defined that function. So let me show you one more useful variable from inside the math module here, which is pi. In order to use pi, you'll have to import it one more time. So if I say pi right now, it will throw a name error because I did not import pi. So instead of importing every individual function and variable name from a module, how can you import everything? You can say from math import star, and that's going to import everything for you. So you'll be able to access pi by typing in pi. Pi variable has a value of 3.1415 and so on. So that's example number 2 here. Let's go through one more invocation of the square root function. I'm going to show you what happens when I call the square root function with minus 16 as the argument. Notice that we are getting an imaginary number. We are not going to talk much about this, but I just wanted to show you that Python is capable of handling imaginary numbers. So let's go through the last example here, which is power function. I'm going to show you the existing power function, which is a built-in function. So I'm going to call POW to compute 2 to the power 3, which will give 8.0 as we expected. Let's create our own definition of the power function. I'm going to call our version as power. We need to provide two parameters here. We are going to configure them as base and exponent instead of using less meaningful variables like x and y. I'm using base and exponent here. The computation itself is very simple. We just need to raise base to exponent here. I'm going to run the function definition. Notice that we did not get any output. That's because we didn't call the function. Let's try to call the function here. I'm going to try the same arguments as before. I'm calling our power function with 2 and 3 as arguments. What will happen here is that the argument 2 will go into the parameter base. The argument 3 will go into the parameter exp here, which is in short for the exponent. Let me run the function call. Notice that we are getting 8 as the output here. So let's go through few more variations with the parameter definitions and the argument passing. Let's say that I want to add a default value to the exponent. I can configure that by typing in equal to and then the default value after that as part of the function definition line. So let me rerun the function definition cell. You need to do that if you want to use the updated version of the function. Let's go through example function invocation where we are using the default value. Let's say that I want to compute 10 squared. I could call the power function just by providing 10 as the argument here. What would happen when I execute this cell? The argument 10 goes into the parameter base. You have not passed any argument for the exponent parameter here, so it will take the default value, which is 2. So what exactly are these types of arguments called? They're called positional. So let's go through example for named keyword arguments so that you can understand the difference between positional and named keyword argument. The way that you will configure named keyword argument is by typing in the parameter name. For example, I can say base equal to 2 in my function call, and then I can say exp equal to 3, and this is going to give me 2 to the power 3. So these are examples of named keyword argument. When you don't use the name of the parameter, the argument is called positional. If you use the name of the parameter, the argument is called named keyword argument. So in order to use named keyword argument, you need to always type in all of the positional arguments in the front, and then finally you need to use the named keyword arguments. For example, if I say power of exp equal to 3 and then 2, Python will be unhappy with that because you have used named keyword argument before positional argument here. How can we fix this? You need to type in 2 comma exp equal to 3 here. I went through a lot of terminology here. I'll wrap up this video. At the beginning of the next video, we are going to learn all about positional arguments, named keyword arguments, and default values.